Welcome to science class. In the last video, I talked about minor members of the solar system. But you know what? Earth is a minor member of the solar system. One of the major goals in this astronomy unit is to inspire you, but also to overturn errors and to show you that things aren't actually what you think they are. And that's not your fault. Space is just so huge that to model it correctly is difficult, and we are very species-centric and planet-centric. It only comes natural. But with this being the end of astronomy, I want to show you just how humbling it can be. This amazing website contains a scale model of the solar system, both in terms of size and distance. If that's how big the sun is, then this truly is how big Earth is, and the distance between them is proportional to their sizes. The idea was to make one pixel on the screen the same size as Earth's moon. Now, with the click of this button down here, we can travel through the solar system at the speed of light, 300,000 kilometers per second. 1, 2, 3, go. Oh, well, that's not as dramatic as I bet you thought it would be. But still, this is what the speed of light looks like in a way we can actually conceptualize. We would have to watch this for 4 hours before we got to Pluto, and more than 4 years before we got to the nearest star. But that's one of only 200 billion stars in this galaxy. This gigantic photograph of the Andromeda Galaxy, the next closest one to us at 2 million light years away, puts some of this into context. Now, as you look at this, understand that the large points of light you see are stars in our galaxy. They are in front of our field of view of Andromeda. The space between galaxies does not contain rogue stars, even though it looks like it does. Now, as this zooms in, just look at the unbelievable density of stars. It looks like they're so close to each other that they nearly touch. But again, that's an illusion. Part of the illusion is that the glare from each star makes it appear much bigger, but also galaxies have depth. So two stars may look like they are right next to each other, but one is light years behind of or in front of the other. The point of looking at this is that this may as well be a photo of the Milky Way galaxy, and any one of these stars may as well be the sun, with an Earth you cannot see, and humans on it you'd have no idea exist. See, this is what I mean when I say, no, we really aren't all that significant in the universe. But it gets worse. NASA decided to take a picture of an empty region of the sky. Now, it may seem like a dumb idea, but remember, discovery happens on the boundaries of what we don't know. Maybe it only looks empty. When you see extremely vibrant photos of stars from Earth or of the Milky Way, no, you cannot exactly go somewhere and the sky will look like that. It's called long exposure photography. The technique captures light from a source over a long period of time and then stacks all of that information together to accentuate the objects in the picture. Hubble spent 10 years on and off collecting light from this tiny sliver of the sky. The field of view is incredibly narrow. Here's how big it is compared to the full moon. This tiny square only represents 1/32 millionth of the sky. Here is what Hubble saw. Apart from these two dots, which are stars in the Milky Way, every single smudge of light is an entire galaxy. Some are close and easy to see, but the tiniest pinpricks of light are extremely distant galaxies. Every single point of light in this field of view is just as diverse and dense with stars and planets as the Andromeda photograph we looked at a little bit ago. There are around 5,500 galaxies in this picture, each containing 2 to 400 billion stars. And again, we could retake this picture 32 million times over in different regions of the sky and get the exact same number of galaxies. This can make you uncomfortable, even sad, but I think it's pretty easy to get over. Then the sense of wonder comes in. How can there possibly be that much stuff out there? It just boggles the mind. The only thing that's really sad, and this actually is terribly depressing, is that we cannot investigate these places to see what they have to offer, what further beauty they have within. We can't even do that within our own local neighborhood of this galaxy. Some people will go as far as to say, you shouldn't show this kind of thing to children. Or, you shouldn't say any of those things, it's belittling and offensive. Well, how pathetic is that, to be afraid of or offended by the truth? This isn't an opinion, it isn't up for debate. Confront it, learn it, get over it, so that you can take control over it. I'll confess that I'm personally really not a religious person at all, and this is a big reason why. The idea that we were put here on this planet for some sort of reason, and that all of this other stuff was created for no reason but to just simply exist, and human activity on Earth is somehow the only objective good or objective purpose in the universe, is wildly improbable and really arrogant. It's really the definition of the universe revolves around you. And that actually does it for Earth science. This course has taken us to so many parts of the globe and to outer space. Of course, there are a few things I still want to cover in the future. I have yet to write any material strictly on oceanography or meteorology, but I hope to in the near future. But it has been a blast creating the course from scratch and learning so many things along the way. Of course, I hope you learned a lot as well. Thank you so much for watching.